Hello friends, how are you? So again repeat, be safe, be happy, stay away from the public places and get protected from the corona. Let's start with our next lecture. What we have discussed into the last lecture, we have actually studied how exactly the systems gets converted, mechanical systems gets converted into the mechatronics system. In this lecture, we have to study how exactly the system, that is the thermal system, can be modeled. Now, as we have studied the mechanical system in the last lecture with the help of Laplace transform, in this lecture we have to study how exactly the thermal system gets converted into the Laplace transform. My friends, the thermal systems gets converted into the mechanical system with the same way what we have gets converted by using the Laplace transform into the mechanical system. Let's see how exactly the thermal system can be. For that, we have to understood the one insulated system along with the one electrical heater that gets suspended into the vessel filled with the what? With the help of liquid into the system, having the resistance, that is the thermal resistance, that is RHL, thermal capacitance, that is the RH, then insulation resistance, that is the RLA, along with the heater temperature of the TM. This is basically the basics of the thermal system. So how exactly the thermal systems can be work. So this is the system that we need to be understood, that how exactly thermal system can be work. So my friends, what is the first law of thermodynamics? So the first law of the thermodynamics is heat cannot be created, cannot be destroyed, but it gets converted into the one form of the energy into the other form. One form of the energy into the other form. So my friends, so as the system can be modeled, this thermal system can be modeled, we have to be, again, in what system we have to be converted? We have to be converted for the application of the Laplace transform, that we have to be converted into the equation of the system. So you betterly understood into the heat transfer what is meant by the conduction. So what is meant by the conduction? Yes. Okay, conduction means the heat transfer from solid to solid. And what is meant by the convection? Yes, convection means solid to other media or the air. So basically we have gets converted into the two, that is the two function, that is TH and the TL, in which we have to convert this system into the system model. Again, as we have applied the Laplace transform same into the which system? Yes. Yes, my friends, in which system? Yes, into the mechanical system. Similar the way we have to be applied for this thermal system. By applying the Laplace transform, we have to get converted into the transfer function, that is a output upon input, and we have to be again converted this system into the thermal system. That's what we have get studied over here. Similar the way system modeling of the hydraulic system can be done. So see here the one part. So this is the kind of the diagram we already studied into the yes, fluid mechanics. Fluid mechanics. So in the fluid, so again my questions to you people, my friends, what is meant by fluid? So fluid is nothing but it is a combination of, or we can call it as air and the liquid or liquid. Okay, so as we have to be convert this system into the system model, we have considered here the cordial along with this flask, or we can call it as a tank, in which the fluid is filled with the height of h with the discharge into this basically a Q. This is the outlet discharge that we have consider it as a Q line. So if you have to be converted into the system model into the mechatronics system, for that we have to be convert first of all the physical system. So what is the physical system? You know, conservation of mass is equal to conservation of the volume of the incompressible fluid. So how the equation of motion for the hydraulic system? Yes, delta Q, that is a Q initial minus Q final, is equal to area into the dH by dt. So here we have considered this flow rate differences, that is a Qi and Q naught, which is the input and the output respectively. So area is the cross sectional area of this tank, okay, so with the height of h. The exit flow rate can be given by this equation, that is a Q naught is equal to GH upon R. What is this R bar? This R bar is the resistance offered to this flow, where it is C. Here it is the R bar, that is a resistance offered to the flow through this output flow, that is the Q naught. So by substituting this all value of Q naught, R bar, we get the equation, that is the H dot Q naught, that is the output discharge, is equal to H naught, that is the height of this liquid, G upon A R bar, that is the resistance offered to this flow, minus 1 upon A into the Q initial. So what is the next step? So all we know, we have to be convert this physical system into the mechatronic system. So for that purpose, what we have to do? Yes, we have to apply the Laplace transform. What we have to apply? Yes, Laplace transform, like this way. What we are applying to the mechanical system. So as we know, what is a transfer function? It is nothing but output upon input. So what is the output? What is the input? So that we have to be gets converted here with the help of this output input. We get as a R bar upon A R bar of S A plus G. This is the final Laplace transform equation or transfer function of the hydraulic system. In this way, we get converted the hydraulic system into the mechatronic system. We get converted into the hydraulic system into the mechanical system. So yes, my friends, so what we have discussed in this lecture? So in this session, basically we have understood how exactly system gets modeled for the mechanical system and the hydraulic system. So the system gets mechanical and the hydraulic system with the help of the Laplace transform. So basically, whenever you have to apply this, or you have to be converted, whenever the question asks you into the examination that how exactly the system gets modeled for the different types of system, that what we have studied here, for that basically what you have to do? You have to be first, you have to be do what? Yes, you have to be convert this system into the first mechanical physical system. What you have to be converted? Mechanical physical system. Then you have to apply the Laplace transform with the help of this physical equation. When you get simplified this equation in the form of this, so you have to apply the basic transfer function. So whenever you apply the transfer function here, similarly this will gets converted into the output upon input. What it gets converted? It gets converted into the output upon input, and you get the system model. So in this way you can get converted a thermal system, hydraulic system into the mechatronic system. That's it. That's it for this lecture. In the next lecture we are going to study a very important concept, that is a poles and zeros. Okay, so thank you guys. Thank you for patiently listening to this lecture. Thank you.